Today we're going to go over section 5.2. Still continuing on with the periodic law, and section 5.2, as you can see, electron configuration and the periodic table. So what you can think back to is what we did in chapter 4, where we wrote those electron configurations. We filled 1s, 2s, 2p, 3s, and so on as we tried to configure or determine the location of the electrons in each of our atoms or elements. In this section, we're going to go over how the periodic table, and I mentioned this a little bit in class, but how the periodic table fits in with this theory of electron configuration. So you can see on this page, the S block elements are groups 1 and 2. The D block elements are 3 through 12. Those are called our transition elements. The P block elements 13 through 18, and the F block elements, those are down below. Those are your lanthanides and your actinides. Okay, so what we're going to go just quickly through is some of your different groups. So we're in the S block. Remember, your groups are your vertical columns on the periodic table. There's 18 of them, and we basically number them 1 through 18. So the alkali metals are group 1, okay? And this just kind of goes, I'm going to pull these all up here for you. This goes through some of their properties. They're very silvery. They're very soft. You can cut them with a knife. They're extremely reactive. They are not found as free elements, meaning you're not going to find them in your backyard or anything like that. They are already combined with other elements to form compounds. They can combine very vigorously with nonmetals, especially halogens. You have to keep them in kerosene or oil if you do have the pure element, because it's extremely reactive with air and with water. The melting point decreases as you go down a group, so that's one of their trends. Another one of their trends is they do get more reactive as you go down the group as well. And they all have one valence electron. So regardless of what energy level that one electron's in, you can remember that, say, sodium is 3s1 and potassium is 4s1 and so on as we go down there. They are all s1s. I also put on in your folder for today a little video to watch where they look at lithium, sodium, and potassium and how reactive they are with water. So group 1 elements are called the alkali metals as a group, with the exception of hydrogen. We're going to talk about hydrogen here in a minute. Okay, the next group are the alkaline earth metals. Those are group 2. Okay, they are harder, they are more dense than the alkali metals, they have higher melting points. They are less reactive because now they have 2 valence electrons, not just 1, but they're still not found as free elements. This is like beryllium, magnesium, calcium, strontium, barium. They're still combined already with other non-metals. If you would find them, they have to be mined, and then they would be separated if you needed the pure element. They have 2 valence electrons. As you can see, that's a filled S sublevel. Remember, the S can hold 2 electrons, and it is filled. Okay. Next, your D block. So your D block are called your transition metals or your transition elements, and that's groups 3 through 12. So we combine all of those together. So it's a lot of elements, that portion right in the middle of the periodic table. And these are like your typical metals, your typical metallic properties that they have. And if you can remember, those are, here they are, I wanted to pull those up. Good conductors of heat and electricity. They're malleable, they're ductile, they have tensile strength, they're shiny. All of these things are these transition metals. And some of those, iron and copper, silver, these are all transition metals. Okay, they're less reactive than alkali metals. They're still reactive. A lot of those do react or oxidize. They have 1 or 2 valence electrons. And one interesting thing, palladium, platinum, and gold, as you know, you can find those as free elements. So you can go and pan for gold and find some gold and become very rich, I guess you could say. Okay. Next is your P block. So your P block is 13 through 18. And these 3 groups, 13, 14, and 15, are all just named after the first member of their group. So group 13 is the boron group, group 14 is the carbon group, and group 15 is the nitrogen group. Their valence electrons are successively 3, 4, and 5. So 13 has 3, 14 has 4, and 15 has 5. They can contain metals, nonmetals, and metalloids. Remember, this is where the zigzag line goes down through. And their properties do vary greatly. Really, the only thing that they have in common for most of them is their number of valence electrons. The next group of the P block is the chalcogens, which is sometimes called the oxygen group, and it has 6 valence electrons. And the name means ore former. So that gen ending means to form, and calc is ore. So they form these ores like iron ore and aluminum ore, bauxite, that are mined so these free metals can be extracted. Okay, next are your halogens. This is group 17. Okay, they have 7 valence electrons. They're the most reactive nonmetals. Remember, the most valence electrons you can have is 8. So having 7, it only needs to gain 1 electron to become stable and fill its outer energy level. So that's why they're extremely reactive. Again, that gen ending is former, and halo means salt. So they do form salts. Fluorine and chlorine are gases at room temperature. Bromine is a liquid. Iodine is a purple solid. And astatine, AT, it's radioactive, very rare form of a halogen. And lastly, in the P block is group 18. These are your noble gases. Remember, we dealt with these when we used noble gas notation in chapter 4 for our electron configurations. This is where you could start because they do have a filled outer energy level. So they do have an octet, 8 valence electrons. They are inert. They're unreactive gases because of that filled outer energy level. Okay, and our last 2 groups for section 5.2 are lanthanides. Those are down at the bottom, 58 through 71. This is the F block. Sorry, I didn't mention that earlier. This is where you fill those F electrons. And the lanthanides are also called the rare earth metals. They're shiny. They're similar in reactivity to group 2. They're in the 6th period in what we call the 4F block. But they are very rare. As you can see, they are found in nature, so they can be mined and extracted, but they are very rare. And lastly, our actinides, 90 through 103, down at the bottom, they are all radioactive. The first 4 are found naturally, okay, up to uranium. The rest are made in the lab. And those ones that are made in the lab are called the trans-uranium elements, the ones past uranium. They are the 7th period, and the 5F block is where those fall in. Okay, and lastly, just in terms of elements in our periodic table, there's hydrogen, which is element 1. It's the most abundant element in the universe. It makes up 76% of our known universe. Most of it has 1 proton and 1 electron. It is a reactive gas. As you know, it's flammable, and it is diatomic. It comes in the form of H2. So that basically brings us to the end of section 5.2. Just a little explanation of the periodic table, sort of in the form of looking at it through electron configurations.